Dear students, we have learned earlier that some materials allow electric current to pass and some are not. Here, this is an electric wire. We are now going to create a circuit using these available materials. So now we are going to add a bulb, wire. Again, obviously we need a switch, again a wire, okay. Now again another wire. As we turn on, we see that the bulb will glow. That means these wires allows electric current to pass. What if we replace the wire and add something like a paper clip? So now we are going to add a paper clip. Yes, now also the bulb is glowing. That means the paper clip is also allowing electric current to pass through it. Okay, let's change it. What if we place an eraser in between these two wires? Is it glowing? No. Let's again off and on the switch. Still not glowing. That means some materials allow electric current to pass through it, but some are not. Like eraser. Eraser is not allowing electric current to pass through it. So we can term it as a non-conductive material, and these are the things which allow electric current to pass through it. So we can term these are as conductive material. Now a question might comes to your mind: do liquids conduct electricity? Let's check it out. We are going to demonstrate an activity. For that purpose, we are taking distilled water, a battery, electric bulb, electric wire, a vessel and some salt. We can see battery and the bulb is connected, and we make one end open from the bulb and other one connector is connected from the battery, and this one is also open. Now what we are going to do, we are going to dip the both open-ended poles inside the beaker and check whether liquids conduct electricity or not. So you can see that this is already a closed circuit. We can light on or off. Just we have to add the liquid, that means the distilled water. So you can see as we are adding the distilled water, the light is not glowing. That means the distilled water is not allowing the electric current to pass through it. Let's try using some salt in the distilled water. You can see as we are adding salts, the electric bulb is glowing. What does it mean? It means that this salt water is now allowing the electric current to pass through it. So we got the answer. Maybe you amazed after observing that pure water does not conduct electricity, but when we add some salt to it, it does. Do you know why? Let's visualize it with an interactive activity. So here you can see there is a water in a beaker. We can pour more water if we want to. Now we are going to add salt here. Before this, we just place battery and bulb here, so it's till now it's not glowing. We are adding salt. As we are adding more and more salt, you can observe that the light is glowing slightly, and you can check the amount of salt here also. As we are adding more salt, the concentration will increase, the concentration of salt will increase, and that increased concentration will allow more ions to pass through it. That's why it's glowing more and more. Have you observed? Okay, that's what we have already observed. Okay, what if we take sugar instead of salt? Will it glow? Let's check this out. You can see we are adding more and more sugar. The concentration of sugar is also increasing, but we are not getting any glow from the bulb. That means sugar or this sugar added water is not allowing the electric current to pass through it. Isn't it so amazing? Salt is allowing the current to pass, but sugar is not. Why? See, you know that salt is nothing but sodium chloride. As we add sodium chloride to water, it dissolves in water and breaks down to individual components and creates two ions. One is sodium positive, another, that means sodium ion, another one is chlorine negative, that means chloride ion. Here you can see green color is for chloride ion and pink color is for sodium ion. Now if we add a circuit and a bulb in the solution, then definitely it will glow, because it will allow electricity to pass through it. That already we have observed. So it will glow. But what if we add sugar instead of salt? Sugar means we can take sucrose. So as we are adding sugar, you can see the sugar is dissolving into water, but it's not breaking apart. No ions formed by the sucrose compound. So if we place a electric bulb and a conductor to here, what we will observe? The bulb will not glow. Why? Because it's not creating any kind of ion here, so it's not allowing the electric current to pass through the solution. If you want to see from more deep inside, then you can observe here. This is a pot having water. So these red and white, these are the water molecules. Red one is oxygen and white ones are hydrogen, H2O. These are the water molecules. As we add sodium chloride into the water, we can see the sodium chloride breaks apart and creates sodium ion and chloride ion. But if we add sugar to the water solution, we can see that sugar is not breaking apart and not creating any kind of ions. That's why it's not allowing electric current to pass through it.